Hey, how's it going, everybody? Victor here. So in this video, we'll take a high-level overview of what redistribution is, and also for whatever reason, I decided to put together VRF or virtual routing forwarding. Both are topics in the CCNP route exam, the 300-101. And let me just say that the redistribution that we're going to look at here is a very, very basic situation. There's a lot more to redistribution. If you want to know more, I suggest you grab a book from Cisco Press or something, because there's a lot more content to it. So redistribution is the act of grabbing some routes in a routing protocol and advertise them into a different routing protocol. Or you could also have the same routing protocol, but different instances of it. So like you could have EIGRP1 and then you want to advertise these routes into EIGRP2, then you'll be redistributing as well. So in this example, we have EIGRP running on the left side of the topology and then OSPF on the right side. And router 4 and 5 are gonna be our two redistribution points. And most of the problems with redistribution, they arise when you have more than one redistribution point. So that's what we're gonna look at here. Let me just take a screenshot real quick. Okay, so this is what we're gonna have. We're gonna have router 4 um, redistributing DCI-GP routes into OSPF, and that's the keyword, into. And we're gonna have router 5 redistributing OSPF into EIGRP. Okay, so and then just so I can show you particular issue, I'm gonna have router 2, which has a loopback called loopback 1. We're gonna having redistributing his connected routes into EIGRP. Okay, so um, so that's what we're gonna do, and then yes. All right, so redistribution has one main issue, and it's the fact that basically you lose visibility. You lose the end-to-end visibility of the network when you redistribute it. For example, when we're doing EIGRP into OSPF, say router 7, he wants to get to router 2 on loopback or something. Okay, so he's gonna recurse to the ASBR because router 4, which is gonna be the ASBR, he's gonna be advertising a type 5 let's say into the network, and then or type 7. Be honest with you, I don't remember quite well. Type 5 or type 7 LSA into the network, and then router 7, he's only gonna know the distance between him and router 4 or the ASBR. He's not gonna know anything behind router 4, and that's the default behavior of redistribution into OSPF. That's a type 2 external route. So you could also have when you're redistributing, you could also you could modify that and type and change into a type 1, and then that will make router 7 consider the distance from his ASBR to the actual destination that he's want to get to. So he'll be considering this one and this one and right there. Okay, but we're gonna look at that. All right, so that's one of the issues. Um, Oh, let me see what else we have. Well, in another thing that is worth mentioning is that when you're redistributing the routes that you want to redistribute are they need to be in the routing table or the RIP table. So, like if you want to redistribute the routes from router 4 um, the OSPF routes or router 5 the OSPF routes into EIGRP, those routes need to be installed in router 5 routing table, otherwise they won't be redistributed. Okay, so I went ahead and already assigned the basic IPs in each interfaces, so that's done. We're just gonna enable the routing processes. So let's go ahead and do that real quick. So router EIGRP1, and we're gonna set the router ID in every router. So and auto network 000, and then router 2, router EIGRP, oops, router ID, and on this one we're gonna say, let me see if I have the, yes, so the loopback. So we're gonna say network or no auto and network 10.0.23.0, and well, if you don't know, 10.0 is all these links, say between 2 and 3 we have 10.0.23, and then the name of and then the number of the router. So this one's dot 2 and this one's dot 3. For example, in router, from router 4 to 6 we have 10.0.46, and then this is dot 4 and this is dot 6. Okay, um so there's that. And then we don't want to enable on this one, we don't want to enable the EIGRP process in the loopback, because we're gonna redistribute that one, remember? Okay, so let's just leave it like that for now. And router 3, say router EIGRP1, router EIGRP, router ID is 30303, and then just enable on every interface. So no auto and network 000. Router 4, we're gonna say router EIGRP1, EIGRP router ID is 4.4.4, and then auto and network we want to enable on the gigabit 2/0, so 10.0.34.0. Okay, and router OSPF1 and router ID is 4.4.4, and uh, I'd rather just enable them on the interfaces, so IP OSPF1 area 0. Okay, router 5, router EIGRP1, and EIGRP router ID is 5.5.5. No auto network 10.0.35.0. Okay, and router OSPF1 and router ID 5.5.5, and then go on the interface and IP OSPF1 area 0. Okay, cool. So router 6, router OSPF1, router ID 6.6.6, and then on this one we're gonna enable on every interface. So we're gonna say network 0.0.0, 255.255.255, or up area 0. Okay, so that should form the adjacency between 5 and 4. Where's 5? Do show IP OSPF neighbors. Okay, it's coming up. Alright, so router 7, we're gonna say router OSPF 1, router ID is 7.0.7.7, and interface IP OSPF 1 area 0, and then okay, alright, that's good. So router 3, we're gonna do a do show IP route, and so you can see right now we don't have any redistribution. So on router 2 we're gonna go ahead and go under the EIGRP process, and now we want to redistribute the connected routes. And all right, so now I guess it's a good time to say, when you're redistributing into OSPF, or I mean into EIGRP, we need to specify a seed metric. And so the seed metric is gonna be Like if you're sitting on router 4 and you want to redistribute OSPF into EIGRP, these OSPF routes, the router 3, he's not gonna know how to handle them because he doesn't know about OSPF routes for now. So that's pretty much what the seed metric does. Seed metric takes care of that, basically translating the metrics from one router protocol to the one that you're redistributing into. So for EIGRP, we need to specify a seed metric every time you're redistributing, or you could say you could set a default seed metric or a default metric, and that'll you should be able to use it for every time you're redistributing into a router. So, in a router. So that's not the case with OSPF. OSPF has a seed metric already installed in it, and it's always 20. So in this case, we're gonna go into the router, into the EIGRP process, and we're gonna say redistribute connected, because we want to redistribute all the connected routes or all the connected uh, interfaces or routes that are not participating in the EIGRP process. So, for example, the loopback one that we have here. So, excuse me. So we're gonna say redistribute connected, and then we need to set a metric, and we're gonna say 1 million kilobits per second and 10 microseconds, 255, 255, 1500 MTU. Okay. All right. So now if we go over to router 3, we should be able to see routers 2 loopback. And here it is. And look at this. It's a 170. The 80 or the administrative distance is 170. That's the default AD for the external EIGRP routes. So keep that in mind. Now let's go over to router 4, and we want to redistribute EIGRP into OSPF. Remember, into is a keyword, so every time you hear into means you need to go into the routing process. So if we want to redistribute EIGRP into OSPF, we need to go to the OSPF to the OSPF process. So router OSPF 1, and we're gonna say redistribute EIGRP, and the AS number is 1. And look at this. We can set the metric. We can set the metric type. Remember, type 1 or type 2. We could set a route map if you wish to deny some of the routes. You don't want to advertise all the routes that the router 4 knows about in the HRP. You just want to redistribute some of them. You could use a route map. All right. So for now, we're gonna say redistribute EIGRP1, and then we're gonna say subnets, because you want pretty much subnet tells the router to redistribute everything, not just the major boundary routes, not just the class A, B, and C routes. So EIGRP1 subnets, and we're not gonna set a metric. Remember, we said the OSPF already has a seed metric installed, which is 20. So hit enter. Okay, and now on router 6, we should be able to see some external type 2 routes, OSPF external type 2. And look at that. Okay, so remember I said the default metric is 20? Here it is. And in OSPF there's no external or internal AD. It's always 110 default. Okay, it's not like in EHRP. Alright, so now let's go over to router 5. Okay, so we want to receive OSPF into EIGRP. So that means we go into the EIGRP process. And for this one, we need to set a metric. So we're gonna do it this way now. Default metric, and then we said 1 million kilobits per second and 10 microseconds, 255, and 1500 MTU. Okay. And now we can say redistribute OSPF1, and that's it. Hit enter. Okay. Now watch this. Um, we're gonna go into router 3 and we're gonna do a do show IP route. Okay, and more specifically, we're gonna say routers to loopback, which is um, or okay. So look at this. We have two ways to get there. So from routers 3 perspective, um, in order to get to routers 2 loopback, he needs to go to router 5. So 10.0.35.5, he needs to go this way. Okay. And also, he knows that in order to get to routers 2 loopback, you could just go this way, right? Alright, so see what's happening here. Let me just take a screenshot real quick. Alright, so see what's happening here. We're going on router 2. We're saying we're redistributing his connector routes into EHRP. So that means when loopback 1, when routers 2 loopback 1 gets into the routing into the EHRP process, it has a 170 AD administrative distance because it's an external EHRP route, so it has 170. So router 4 knows about it. All right. So router 3 knows about it. He advertised it to router 4. Router 4 knows about it, and then so because it's an EIGRP route, router 4 advertises it into OSPF as well. And when this route gets to OSPF, it comes in with a 110 AD. Remember, OSPF only has one AD for both internal and external. It's 110. So router 6 knows about it, and then he advertises it to router 5. All right. So router 5, this is a key point. Um, router 5 knows two ways to get to routers to loopback. One is through the in his routing. Oh, let me just show you. Right here. Well, yeah, he knows two ways to get there, but he only installs one in the routing table because it's the one um, with the lesser AD, the lesser administrative distance. So he installs this one because it's 110, and even though the one on his left side is closer to him because it's just right there, only 2 hops away, um, he rather install this one in his routing table because it's a lesser administrative distance. So obviously we have a problem here. So so in order to solve that, we're gonna say the problem is on router 5. Right? He shouldn't be advertising that route again into HRP because it's a mistake. He's taking a route that originated in this side, was redistributed into OSPF, and then because it now has a lesser AD, he's advertising it again into AHRP. So he shouldn't be doing that. All right. So there's two ways we can solve this. We could sit on router 5 and tell him not to advertise that particular route back into the EHRP process, or um, we could go into router 6 and telling not to advertise that particular route to router 5 because router 5 he doesn't need to know about it because he can just if he needs to get to router Zulu back he can just go to router 3 and then to router 2 so he doesn't need to know about that. So let's go on router 6 and let's roll out distribute list. So for that, we're gonna say access list, and we're gonna say access list one deny, and we need to deny 21, 21, 21, 21, and 255, 255, 255, 255, or actually 0, 0, 0, 0. It's a wild card. Okay. Um. and then go into the routing process. So router OSPF1 distribute list. We're gonna say the access list number is 1, and we want to filter going out. So going out interface once /0 going towards router 5. So out and then gigabit /0 without for OSPF. Oh, okay. Alright, so what we're gonna do is down on router 5, we're gonna block incoming advertisements from router 6 telling about the router's to loopback. So we're gonna say exit out of here and access list 1 deny 21 21 21 21 and 0 0 0 0. Okay, so router OSPF 1 and distribute list 1 in gigabit /0. Okay, cool. Now let's just go ahead and do clear IP OSPF process. Say yes. Alright, so now router 5, he shouldn't know about routers to loopback from the OSPF AD or the OSPF process. So uh, in his routing table, he should only have installed the 170 EIGRP, the external EIGRP route. So do show IP route, and there we have it. Okay, so now if we try doing a pin, should be successful. That's right. Okay, so on router 4 or router 6 IP route, he should still have installed the one with 110 coming from router 4, and yes, he does. Okay, so that's pretty much what redistribution looks like when you have more than one redistribution point. Again, main reason that you're not gonna run into troubles when one of the routing protocols is CHRP is because it has two different ADs, one for the internal, one for the external. So does BGP, and so if you look at the HRP's ADs, the internal is 90, and then the external one is 170. In BGP, or at least in Cisco, um, the external BGP is 20, and then the internal BGP is, I believe, 200 or 220, not sure. So and the reason for that is because BGP um, is an external routing protocol. So it was meant to route uh, it was meant to route on the internet. So that's pretty much why the external routes in BGP are preferable than the internal BGP routes. And it's the other way around with EIGRP, because EIGRP is an interior gateway routing protocol. So um, that's pretty much it. So now let's just take a quick look at what VRF is. And just give me 1 second. All right, so we're just gonna drop these three routers here. Two, three, and one. Okay. All right, so imagine we have imagine router 2 and 1 are two, or let me just take a screenshot. All right, so imagine router 2 and 1 are two different customers. And then router 3 is is our the provider edge router. So this is the PE, and these are the two oops, uh, customer edge or customer routers. So um, So the thing is that we don't have control over what internal routes these particular clients are have in their infrastructure. So they could have the very popular 192.168.0.0, and so does he. 192.168. What's that 0.0, right? So router 3, he needs to have a way to separate these two, okay? So that's pretty much what VRF accomplishes. VRF, or the virtual routing forwarding, it's you could think of it as you could compare it to the VLANs in the way that a VLAN pretty much splits the switch into different virtual switches, right? So like if you have um, I don't know, 8 ports in Switch, and then you put four of them in a VLAN and the other four in a different VLAN, and a different VLAN. They have two different broadcast domains, right? So something you connect into this port is not gonna get to a port in the other VLAN uh, unless you enable the IP routing and then set gateways for the VLANs, or you have a routing stick kind of thing. Okay, so in a BRF, it's pretty much the same concept. You have one router, and then you could create virtual routers within this router. So pretty much everything comes down to this fact. You have two different routing tables. So we're gonna have a router table for this VRF instance called VRF, I don't know, VRF lower score A, and then VRF B. Okay, so we're gonna have two different instances, and there's gonna be a routing table for each instance of the VRF. So let's just look at that real quick, okay? So on let's just go on the router 2 and say um, we're gonna do config interface 0/0 IP address 10.0.23.2.25.25.25.0 not shot, and then router 3 32 oh, 23.3.25.25.0 not shot. Okay, on router 1 interface 1/0 IP address 10.0.13.1.25.25.0 no shot. Okay, all right. So now if I do or I shouldn't have configured router 3, but doesn't matter. If I do a show IP route, okay, I have these two links in the same routing table. So I'm gonna create two different VRF instances. So I'm gonna say I, IP VRF, and gonna give it a name. It's gonna be VRF A, and that's it. IP VRF B. Okay, now I'm gonna assign these two interfaces to the corresponding VRFs. So interface 0/0, I'm gonna say VRF or IP VRF forwarding, and it's called VRF A. Okay, and look at that. Interface disabled and addresses removed due to enabling VRF. So that means we need to give it the IP again. So it's IP 10.0.23.3.25.25.25.0 not shot exit, and then IP VRF forwarding VRF slide lower score B, and then IP address send dot 0 dot 13 dot 3 25 0 no shot. Okay. Now, if I do a show IP route, there's nothing. Okay, because like, as I said, we have two different routing tables now. So we need to do show IP route VRF and the name of the VRF, which is VRF A or VRF B. Okay, so that's pretty much what VRF Lite is about. They call it Lite because they only use it they mainly use it just to roll out these kind of services. But there's a lot more that you can do with VRF. And on the customer side, there's nothing going on. Like there's just the regular routing table that we're familiar with. Okay, so that's pretty much what VRF is. If I try from router 3 and I say ping 23.2, it's not gonna be successful because we haven't. Remember, it's in a VRF, so we need to specify the VRF that we're trying to ping from. So ping VRF, VRF A, and then the IP 2. Okay, so that's pretty much what VRF Lite is about. Um, Now, like if you were in a, let me just take a screenshot and now if you're a service provider and say this is your core network, this one right here, or this one, and so this is your core MPLS network. So you right here you have another router and then another router and then another and stuff like that. And these two routers, router 3 and 6, are your provider edge routers. So these routers are servicing different customers. This one, okay, and they're connecting to the same customers on the end of your MPLS network. Uh, Pretty much router 3 and 6, they're gonna have different VRF instances for each customer that you have. And so more likely there's gonna be internal BGP adjacency between router 3 and 6. So they're going to be sharing their information about the customers. And so, say router customer A over here is trying to reach customer A on this side. He's going to send a packet to router 3, and then it's going to come in a particular VRF instance, and through a route distinguisher, he's going to be able to send the packet across the MPLS cloud or the MPLS network, and then it's gonna end up coming into router 6, and then with the route distinguisher, he's gonna be able to know where to forward the packet to. So he's gonna know that he needs to send it this way in order to get to customer A again. And that's for a high-level view how VRF is implemented in MPLS network. Um, I might be able to show you that in a next video or in an upcoming video. Uh, right now I'm mainly focusing on SDN or software defined networking, and because I want to be able to bring videos to you guys, and I want to be able to shoot some videos about SDN and pretty much how to practice on Mininet, set up virtual switches, um, and then managing them from a controller, pushing APIs and stuff like that. That's I have a long way. I have a long way to go on that. Be honest with you, I'm not very familiar with Python or any programming language. So I indeed have a long way to go. But that's I've been attracted to lately. Let me just. Oops. So, like if you look at the um, let me see. So I've been trying to work with pucks, which is an SDN controller, and so I have my mininet here. I have the um, three different nodes, host one, two, and three, and this is my Wireshark, and it's be honest with you, I don't even know what it's doing right now. It's just capturing the loopback. Um, so that's what I've been working on lately. I haven't had much time to be honest. I'm about to move to a different apartment, so I've been having to move a lot of stuff around. Um, but that's pretty much what I wanted to show you for now. I hope this has been informative for you, and I'd like to thank you for viewing.